As part of my problem series, in this video, we will be calculating the current and impedances of this parallel RLC circuit. Once I am finished with this series of problems, I will be posting them in my stand store at this web address. In this problem, we are to calculate the impedance of the parallel RLC circuit and the individual currents flowing in the resistor, the inductor, and the capacitor. The angular velocity is given by omega, which is equal to 2 pi f, where f is the frequency. Plugging in actual values, we get 2 times 3.14159 times 60, which is equal to 377 radians per second. C equals minus 1 all over omega c. With actual values, xc is equal to minus 1 all over 377 times 26.5 times 10 to the negative 6, which comes out to minus 100 ohms. XL is equal to omega L. Therefore, XL in real terms is 377 times 0.5, which is equal to 188.5 ohms. We will use the voltage as reference again. Therefore, E is equal to 200 at 0 degrees volts. It's a phasor, and it is shown here in blue. From Ohm's law, the current in the resistor is IR, and that is equal to E all over R, or 200 at 0 degrees, divided by 100 at 0 degrees, which is equal to 2 at 0 degrees amps. Its phasor is shown here in red. From Ohm's law, IL is equal to E all over XL, or 200 at 0 degrees divided by 188.5 at 90 degrees, which comes out to minus J 1.06 amps. Its phasor is shown here in red. 1.06 amps at minus 90 degrees. From Ohm's law, IC is equal to E all over XC, which is equal to 200 at 0 degrees divided by 100 at minus 90 degrees, which is equal to plus J at 2.0 amps. Its phasor is shown here in red, 2 amps at plus 90 degrees. Again, note that in my diagram, the magnitudes of the phasors are not necessarily exactly to scale. They are meant for demonstration purposes only. IT, the total current of the circuit, is the vector sum of 2 plus J2 minus J 1.06, which is equal to 2 plus J 0.94, which ultimately equals 2.21 at 25.2 degrees amps. Adding the vectors, we start with the current IR, which is 2 amps, and add it to the current in the capacitor, which is IC, 2 at plus 90 degrees, and add it to the current in the inductor, which is IL, minus 1.06 at minus 90 degrees. So summing the phasors, or vectors, we get IT is equal to 2 plus J 0.94, or 2.21 at 25.2 degree amps. The impedance is ZEQ, which is equal to E all over IT, which is equal to 2 at 0 degrees all over 2.21 at 25.2 degrees, which comes out to 90.5 at minus 25.2 degrees ohms. So we calculated the impedance of this parallel RLC circuit and the currents in R, L, and C, and we're done. You'll find these problem-solving skills come in handy when you're automating your home. especially when using Z-Wave products such as these lighting switches that are extremely versatile. With them, you can create a mood accented by the lighting. Mood lighting is easy. Let's set the scene for movie night or a romantic dinner. With Z-Wave light switches and bulbs connected to your Z-Box hub, it creates the perfect ambience in just a tap away. Dim the lights, change the colors, or set up automatic scenes. Movie night, dinner party, your hub's got you covered. For many, smart lighting switches are the first things that come to mind when considering the benefits of home automation. Controlling your lights is one task that you are certainly willing to delegate to a smart assistant to home automate, schedule events, and respond to activities in your house, and even support your verbal commands. Browse the wide range and selection of Z-Wave switches and lighting control options. Not all Z-Wave switches are compatible with your Z-Wave hub, so they've made it easy for you to shop by selecting your hub model to find the switches and dimmers that will integrate with your Z-Wave network. Z-Wave switches are the ones that you can control your home lighting from your smartphone, Alexa, or Z-Wave controller interface. The configuration options for your lighting are endless. Find the best prices online at this web address. If you are ready to elevate your living space with home automation, now is the perfect time to transform your home into a smart, efficient household. In order to explore an incredible range of innovative products that cater to all your smart home needs, simply go to this web address. Don't miss out on exclusive discounts available for a limited time. Take the first step towards a smarter home and discover how easy it is to enhance your lifestyle with cutting-edge technology. Your dream home awaits you. And I would remind you that there is no cost or no charge for simply looking at what's available. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.